welcome to the Crazy Hat Chemist. So another video here today on bonding, so let's get moving. Bam! Today we're going to draw the Lewis dot structure number 13, and we're going to draw the Lewis dot structure for xenon tetrafluoride. So xenon is a noble gas, and then tetra is for 4, and fluorine is a halogen. So write out that structure here, xenon tetrafluoride. Hopefully that makes sense. Now what we're going to do is we're going to get the number of valence electrons on xenon. That's 8. Valence electrons on fluorine, that's 7. And total number of fluorines, that's 4. I'm going to add these two numbers up. I'm going to get this number 36. I'm going to divide 36 by 2. So I get now 18 pairs of electrons. The least electronegative element, that goes in the middle, and that is the xenon. Now I'm going to place the fluorines around the xenon as is appropriate, just like that. Now I'm going to place these 18 pairs of electrons according to the rules, and that is first, I'm going to place a bonding pair of electrons, a single or a sigma bond between the central element and the outside elements, and that is done just like that right there. I still have plenty of electrons left over, so I'm going to place lone pairs of electrons around the outside elements, and that's around the fluorines. And I'm going to place 3 sets of lone pairs of electrons around each fluorine, and I have done that there. Now, I still have some lone pairs of electrons yet remaining, so I'm going to place those lone pairs of electrons and dump them right there in the central element, just like that. Okay, so xenon is most certainly period 3 or greater. That's 3, 4, 5, or 6, or 7, and it can exceed the octet rule, and that is it can be hypervalent. Okay, now what we're going to do is we're going to clean this structure up, make it look really pretty. We're going to draw lines for single sigma bonds and keep those lone pairs that are in purple on the central element as lone pairs, as well as the lone pairs on the outside elements of fluorine. Okay, we also have verified the octet rule for fluorine because, of course, fluorine must obey the octet rule. So here's our structure cleaned up, looking nice and pretty here. I got 4 single or sigma bonds attached to that xenon in the center with the fluorines on the outside, and 2 sets of lone pairs of electrons on that xenon. Okay, that is another cool crazy hat video, and here's another crazy hat. If you like that video, give me a thumbs up, subscribe to my YouTube channel, I'd greatly appreciate that. Have a delightful day. See you next time. Bye now.